Alright, number 29. I think this is probably the best example of this homework problem, of this homework assignment that we've done so far as me answering your questions because of everything that it has in it. Okay? One word to start this off. What do you think that one word I would want you thinking of? Rewrite. It's all about the rewrite. What would y'all start to rewrite here? Dividing the top by root u. So you would rewrite. Okay, so here we go. We could do either one, but either one is good and effective. I can change the bottom denominator to this. Okay? So that you still have u minus 6 in respect to u from 1 to 4. But then further, I know that from 5th grade when we started adding fractions, if the denominator was the same, we could combine these to one big fraction. What we are doing now to make manipulations easy is that we're breaking it and we're going backwards with it. Okay? So that we could rewrite this as u over u to the 1/2 in respect to u from 1 to 4 minus 6 over u to the 1/2 in respect to u from 1 to 4. Okay? What do you think I would do next? Rewrite again. I would rewrite again. You have two choices here, and I heard them both. I could bring this up. I could bring this up with a negative if I wanted to. I don't know if I've said it already in the Ed puzzle, but you'll see that I say it all the time. Should you bring that one up? No. You should only bring that up if and only if the top numerator is one term and it's a what? Constant. So here I would just use algebra 2 skills and know that I have u to the 1 over u to the 1/2. Guys, what do we do with powers when we're dividing with same bases? Subtract. So 1 minus 1/2 is a positive u to the 1/2. That's the antiderivative for this first one. And we're going to evaluate it from 1 to 4. Okay, I'm not going to put this one all together in one big one the way I did the other one. Either way will work. Either way will give you the same answer. Alright. Should I bring this u to the 1/2 up? Yes or no? Yes. Because the top is one term and it's a constant. So, notice, when I do that, I haven't yet integrated, so you have to be careful of where you are with your step. I haven't yet integrated. What do you think I would probably do next from this piece right here? Constant multiple rule. Yeah, I would integrate it, but I mean, what I'm wanting to instruct you right now is, to simplify stuff, I would constant multiple rule out a what? 6. So now, in respect to u, I'm only integrating this integrand of u to the 1/2. Reverse power rule. What do we do to that negative 1/2? We add 1. Okay, here we go. So negative 1/2, I'm going to add 1. Remember, I want that common denominator. So if I add 1, what does that new power become? 1/2. Divided by 1/2 or multiplied by 2 over 1. And this one's going to be evaluated from 1 to 4, and it is subtracted. And what am I missing? This is 6. I got to constant multiple rule this 6 back into here and make it a 12. Multiply it back in. That's what it's called, constant multiple rule. Okay. So now there's no plus c. Brooks, why is there no plus c?
Because it is a definite.
Perfect. It is a definite integral. There is no excess. It's bounded. Okay? Bounded won't have plus arbitrary error. Okay? Here we go. So let's put 4 in here. And we're going to take what? The square root. So we get 2 minus, let's put 1 in here. And it's going to be what? 1. So this first answer right here is going to be what? 1.
Wait, how did you do the 1/2 to the 1?
Integrate that.
Yeah, did you integrate u to the 1/2?
Did I ever integrate 1?
I don't think you did.
Ooh, nice catch. No, I did not. So u is u to the 1, subtracting 1/2, I'll give you participation points, becomes u to the 1/2. I never integrated it. And those are mistakes. Those are mistakes that will happen also with you. Is if you break them up, and this happened unexpectedly. That's good that it did happen though. If you break it up too much, can you forget to do things on others? Yes, you can. But whenever you have it all as one antiderivative, that happens a lot less. Okay, because you have less to keep track of what's been integrated, what has not. Thanks for that. So u to the 1/2 will actually become u to the what? 3/2 times what? 2/3. So 3/2, 2/3. Thank you for that. Okay, here we go. Let's plug in 4 right here. We're going to take the what of 4? The square root. Okay, so let me clean some of this up so that you're not looking at too much stuff. Okay. So plugging in this 4, we're going to take the square root first, which is 2, cube it, which is 8, multiply by 2, which is 16, and it's over what? Is it a negative 3? No, just a 3, right? My bad, this was there. Okay. And we're going to subtract what we would get if we plugged in 1. What is that going to be? 2/3. All of this is the first answer here, which we were circling over here. Okay? Next one. When I plug in 4 here, the square 4 here, the square root of 4 gives me 2, so that will be 24. Plugging in 1, what would I get? 12, because the square root of 1 is 1, times 12. Remember, you are subtracting each of these pieces. Okay? It's going to be plugging in the top minus whatever you get when you plug in the bottom. Keep track of your minuses because this minus came from the original problem right there. Not from the f of b minus f of a. 16 minus 2 is 14/3. 24 minus 12 is 12. We are subtracting. To get a common denominator, I'd multiply by a form of 1. So it's 14 minus 36 all over 3. So it's a negative what over 3? Negative 22. Plus c, yes or no? No, because it's not an indefinite. Nice catch. Good mistakes that we just did on that. That's a really good problem, okay? That's the heftier one out of the ones that we did today.